To create these authorization rules, usually we create something called authorization matrix for the subject, objects, actions, and the constraints. This slide shows an example of the authorization matrix. This matrix has 4 columns, like subject, object, action, and constraint. Subject refers to the user or a group of users. Object refers to a data element or data object in the database. That can be a table, can be a record, can be a field. And action refers to actions you can perform on the data, like insertion, deletion, update, and so on. And constraint would be, what are some of the allowable actions and some of the not allowable actions. For example, in the first record, it says the subject is the sales department. So the sales department is allowed to insert customer records into the database. Right? However, it can only insert customer records of the customers who have a credit limit that's less than $5,000. If the customer has a credit limit over $5,000, then the sales department has to get approval before they can insert a record into the table. The last one here, it shows that program AR4, so that's referring to an application program, right? Will be able to modify the order record in the order table in the database, and there is no restrictions. So basically, the program will be able to modify any record in the table. This line shows that Ann Walker, who is a user of the database, is allowed to insert into the order record, but this person is only allowed to insert orders that are less than $2,000. So that's an example of the authorization matrix. However, in the database management system, we often use something that's simpler than the authorization matrix to define the roles and authorities of different users. What we use would be something called authorization table for subjects or authorization tables for objects. The first example here is an authorization table for a subject, for a user or a group of users. Right? For example, that's the authorization table for salespeople. So for salespeople, right, they can read the customer records, they can insert into the customer record, they can modify, however, they cannot delete the customer record. And they can read the order records, they can insert into the order record, however, they cannot modify or delete the order record. So that's an authorization table for a particular user or a group of users. Then we also use the authorization tables for objects. And objects are referring to the data elements or data objects. In this case, the object is the orders table. For this particular table, the salespeople can read but cannot insert, cannot modify, cannot delete. And the people who are doing the order entry, they can read, they can insert, they can modify, but they cannot delete. And for accounting people, they can read, they cannot insert, right? They can modify, and they can delete. So usually in a DBMS, we will use these authorization tables for subjects or objects to define the privileges of different users on different data elements. This picture here shows you some of the privileges you can assign to different users. And this uses the Oracle database as the example, but in SQL Server, these privileges are pretty much the same. Right? You can assign select, insert, update, delete, alter, index, reference, and execute to different users. In SQL command, what you do is you use the grant or revoke command to assign or revoke privileges. For example, if I say grant select on product table to J. Smith, what this command does is it will grant the select, which is the query ability, on this product table to this user whose username is J. Smith. And if you want to revoke the right, you just need to change the word grant to revoke, and that will revoke the privilege from the user. Encryption, that's another way to secure the data. And there are two types of encryption. One is the one-key encryption, or it's called the symmetric encryption, and the other is the two-key encryption, or asymmetric encryption. Right? And this picture shows you the asymmetric or two-key encryption. Basically, everybody has what's called a public key, and the company has the private key. when trying to do business with the company, they will be sending their credit card number or other confidential information encrypted using the public key to the company. And if the information is intercepted during the transmission, nobody can read it because you really need the private key to decrypt the message. So only the company that has the private key will be able to decrypt the message. So that's probably the most popular way of encrypting data and information in business transactions. And sometimes we may want to encrypt the data that's on the hard drive, because sometimes the hacker may be able to access your hard drive. That depends on how much security you need. For certain companies, they may just encrypt the credit card number field in the customer table. For some companies, they may want to encrypt the whole customer table. So for some companies, they may even want to encrypt the whole hard drive if they have really sensitive information. So it really depends on the nature of the data you have. Authentication scheme. The goal of authentication is to obtain a positive identification of the user, to ensure that the user is who she says who she is. And the most common tool for authentication is password. That's usually the first line of defense. And there are also some recommendations for a strong password. You want to change your password frequently. You want to make sure that your password is at least 8 characters long. There are software tools out there that will help a hacker crack the password. The way they usually do it is they will use a combination of numbers and letters and try to figure out what the password is. So the longer your password is, the longer it's going to take this software to crack the password. Pretty much every password is crackable. I guess the thing you want to do is to make sure that it's going to take so much effort and time to crack the password, and the hacker decides to give up eventually. Usually there are 3 ways to authenticate a user. One is by something the user knows, like for example a password or PIN number. Another way is by something the user have, for example a smart card or a token or key. And then the third way is by some personal characteristics of the user. Like for example, the fingerprint, the retinal scan, or using the facial recognition systems. If you want to have more secure the setting, you may even want to use the 2-factor or 3-factor solutions. The 2-factor solution basically means you need to use 2 ways to authenticate the user. Maybe one is with a smart card, and the other way is a PIN number or password. And the 3-factor basically means you use 3 ways to authenticate the user: a smart card, a biometric, and a PIN number. The more ways to authenticate a user you use, the more secure the system is going to be. Besides all these technical countermeasures, you also need to have some of these managerial countermeasures. You want to make sure that you have control over the personnel you hire in the company. So the hiring practice, make sure you do a background check. And the employee monitoring, it's illegal for companies to monitor employees' activities on the internet or on the company computers. It's not legal for companies to monitor what the employee is doing on their own personal computers, but it's legal for companies to monitor what the employee is doing on their company-issued computers. Make sure there is security training. You never see a room that has a sign on it saying server room, because that's really inviting people to come into the room and destroy your computers. So you want to make sure that people don't have the physical access to your sensitive equipment. Maintenance control and data privacy controls. Right? So those managerial countermeasures are just as important as these technical countermeasures for security. And let's talk about database recovery. Sometimes your database may be destroyed or corrupted, and you need to find a way to recover your database so you can resume your business transactions. And that's a very important responsibility of the database administrator, because today the hacking activity is increasing. And the hackers are hacking systems randomly. They're not just focusing on a handful of large corporations anymore. Sometimes they are just randomly looking for vulnerabilities on the internet to see which company has the vulnerability that they can hack into. So there is a lot more hacking activities going on these days. Fortunately, a lot of these activities can be detected by the tools, the DBMS, and some of them probably are more severe and requires human intervention here. Right? But most of them can be resolved just by DBMS functions. Data recovery refers to the mechanism for restoring a database quickly and accurately after the loss or damage. And a number of facilities we use for recovery: backup facilities, journalizing facilities, checkpoint facilities, and the recovery manager. Let's take a look at these 4 facilities. The first one is backup facility. You need to back up your database on a regular basis. For most companies, the backup procedure is written in a procedure so that every day, maybe at the end of the business, the procedure will be activated and the backup will start. You can do what's called a cold backup, which means the database is shut down during the backup. And in order to do a full backup, you really need to shut down the database, making sure that there is no new updates to the database. The only way to get a full backup is through the cold backup. However, for some companies, this may not be possible because their database needs to be run on a 24/7 basis. So you may have to do a hot backup, which means you will back up certain portions of the database that's shut down while keeping other portions still running because you need to continue your business. For some companies, they may also decide to do something called an incremental backup. An incremental backup basically means we are only backing up the differences in the database since the last backup. So why do you want to do incremental backup? Well, maybe it's because the full backup takes too much time. And we wouldn't be able to shut down the database for so long to do a full backup, right? So in order to save time, we can only back up the differences in the database since the last backup. And in case of database destruction, what you can do is you can find the latest full backup and then apply all these transactions in the incremental backup to the latest full backup to restore the database to the current status. And the backups should be stored in a secure off-site location. You always want to put your backup in a different location in case the building is on fire or if there is an earthquake in the region. You want to make sure that your backup is just as far away as possible. These days, a lot of companies do a remote backup through the network so that the data can be backed up in a very far away location from the company. Some companies these days are doing something called a fallback. And the fallback is basically a real-time backup. When any updates being applied to the database, the update is also instantly backed up on another server remotely. That's becoming more and more popular. The second facility we use for recovery is the journalizing facility. The journalizing facility keeps a log of the activities in the database. There is what's called a transaction log, records all the essential data for each transaction processed against the database. Right? So when we need to restore the database, we can apply the transaction logs to the latest backup to rerun all these transactions to restore the data to the current status. There is also what's called a database change log. In the change log, it has the before image of the modification and the after image of the modification. So for example, if the price was changed from 700 to 750, so it will have a before image of 700 and after image of 750. And that's also important in restoring databases because we can find the latest backup and then apply all the after images to the data in the latest backup in order to restore the database to the current status. There's also what's called security log, which will inform the DBAs of any security violations. If somebody is trying to access the database without authorization, this can be reported to the DBA for further investigation. We also have what's called a checkpoint facility. And the checkpoint facility means that during the transaction, the DBMS will periodically refuse to accept the new transactions, which puts the system in a quiet state. And the checkpoint facility is going to take a snapshot of the data at that checkpoint. So it's a snapshot of the database between full backups. And the reason for that is because this way you don't have to go all the way back to the latest backup. You only need to go back to the latest checkpoint to restore the data. So that makes data recovery faster. What's the recovery and the restart procedures? Well, there are a number of ways to recover a database. Probably the best way to recover a database is if you have a mirror disk, which has exactly the same database as the production database. In case of a database destruction, you can quickly switch to the identical copy of the database and resume your business. So that's the fastest way to recover, and it's also referred to as hot swapping. It causes almost no disruption to the business. However, it's also pretty expensive because you have to have multiple databases. Besides multiple databases, you also need to make sure that the backup is a real-time backup, so which can be pretty expensive. And then another way to recover your database is something called the restore and the rerun. That means finding the latest backup copy of your database and then finding your transaction log and then rerun every transaction since the last backup in order to restore the database to before the destruction. So that's called the restore and the rerun. It takes more time, definitely, and also the time it takes to restore the database depends on how many transactions you had since the last backup, right? The more transactions you had, or the longer time has elapsed since the last backup, the longer it's going to take for you to restore the database. Also, there is what's called the rollback and the roll forward ways for backing up databases. Let's see. Let's first look at the rollback. If your database is corrupt during a transaction, let's say for a transaction there are 10 activities. However, your database is only able to perform 5 of these activities and then something happened. In order to ensure the integrity of the transaction, you need to make sure that these 5 activities are rolled back. What you will do is you start with the current database and then roll back 5 steps so that your database is back to the state before the transaction. And the roll forward basically means you find the latest backup copy of your database and then you are going to apply the after images from the change log to move the database to the state before it crashed. This is more efficient than the restore and the rerun. The restore and rerun, you're going to reapply these transactions. But in this roll forward, you're only applying the after image. Right? So it's a lot more efficient than reprocessing these transactions. Remember, we talked about transaction in SQL. That you can have SQL perform a number of actions together as a transaction using begin transaction and end transaction. And between begin transaction and end transaction, you can have a number of SQL commands. For a transaction to be a transaction, you need to make sure that it meets these requirements. The transaction must be atomic, which means these transactions cannot be subdivided. All of these actions must be performed in its entirety or not at all. And the transactions must be consistent, which means the constraints don't change from before the transaction to after the transaction. And the transactions need to be isolated, which means the intermediate results are not going to be released to the user until the whole transaction is completed. Also, the transaction needs to be durable, which means the result or the changes to the database needs to be permanent. You can use commands like rollback to roll back a transaction, to void a transaction. If the transaction performs successfully, then you can use commands like commit to commit the changes to the database. And sometimes if the transaction is very long, has many steps, and you don't want to roll back all the way to the beginning of the transactions, you can also create checkpoints in the transaction so that you can roll back to a certain checkpoint. On this slide, we have a number of database failures and how to respond to these failures. For example, the first one is aborted transactions. You are performing a transaction and in the middle of the transaction, something happened, right? So the transaction didn't get performed. So what's the preferred recovery method? It's to roll back to the beginning of the transaction so you can reprocess the transaction. If we have incorrect data, we found that there is incorrect data in the database. What can we do? Well, the preferred recovery, again, is rollback to make sure that all the incorrect transactions are rolled back and then reapply all the transactions. An alternative would be to rerun the transactions without including inaccurate data updates. Right? So you find the latest backup and rerun the transactions without the incorrect data. And another alternative is to compensate the errors in the transaction. For example, in the transaction, somehow you added the $10 extra to the amount. And then you can conduct a compensating transaction to deduct $10. If your system is destroyed, however, the database is still intact, the preferred recovery method is switch to the duplicate database. If you have another database, switch to the duplicated database. An alternative would be to roll back to the previous state and then restart from the checkpoint. If your database is completely destroyed, then the preferred recovery obviously is to switch to a duplicate database. But if you don't have a duplicate database, you can find the latest copy, the backup copy of the database, and roll forward, apply all the after images to quickly restore your database. Or the other way is to reprocess the transactions from the latest backup, right, to restore the database.